Look at question 10b. An engineer uses a concave spherical mirror to inspect the insides of a pipe. The mirror has a radius of curvature of 40 centimeters. I said we should calculate the focal length of the mirror. Now let's try visualizing it. Now we have our concave mirror. We have the distance from the pole to the center give us the radius of curvature. We know that the radius of curvature is the radius of the circle from which the spherical mirror is believed to have been carved out of. So the radius of curvature spans from the pole to the center, and the focal length is half of the radius of curvature. So we've been given radius of curvature in our question as 40 centimeters. And we've been asked to find focal length. And from the diagram, focal length is radius of curvature divided by 2. So if you have been given radius of curvature as 40 centimeters, if you divide by 2, you get your focal length to be 20 centimeters. So this is my I for focal length. Now the question says we should calculate the position and magnification of the mirror. If the mirror is placed 10 centimeters away from the crack, it means that we've been given object distance. So we've been given object distance U to be equal to 10 centimeters. And we have our focal length here to be 20 centimeters. So using the mirror formula, 1 over F equals to 1 over U plus 1 over V. I'm just going to substitute my values in them straightforward. So I'm having 1 over 20 to be equal to 1 over 10 plus 1 over V. I have only one unknown. The rest of is algebra. I'm just going to make V the subject. Whatever I get is my answer. So I will send this to the other side and get 1 over 20 minus 1 over 10 equals to 1 over V. So let me do some algebra here. The LCM here is 20. So 20 goes into itself, 1 minus 10 into 20, 2. And that will be equal to 1 over V. So this, when you simplify this, you are going to get negative 1 over 20 to be equal to. So since this is the inverse, if we are looking for V, we have to find the inverse of negative 1 over 20 as well. Therefore, our negative 20 over 1 is equal to V over 1. Therefore, I can say from this point that my V, which is image distance, is equal to negative 20 centimeters. And now let's find the magnification. We know that magnification is equal to image distance over object distance. Now we know our image distance as we calculated right now and the object distance given in the question. So all we need to do is to substitute. Our magnification is equal to image distance, which is 20 centimeters, divided by our object distance, which is 10 centimeters. So our magnification is equal to 2. Magnification has no unit, so magnification is equal to 2. I says we should state the nature of the image. So the nature of the image, the first thing we know is that since the magnification is greater than 1, we can say that the image have been magnified. So the image have been magnified because our magnification is greater than 1. Then our image distance is negative. Our image distance being negative indicates that our image is virtual. The image is virtual. And then looking at the position of our object, the object is likely to be between the pole and the focal length. And anytime you have an object here, you mostly have a virtual image. So you have this not drawn to scale, it will come down here and trace back up here. So you get your image somewhere up here. So you get a virtual image, you get a magnified image, and then you get an upright image. The focal length is 20 centimeters and the object distance is 10 centimeters. So the focal length is 20 centimeters, the object distance is 10 centimeters. So it is definitely between the pole and the focal length or the principal focus. So the image that will be formed will be virtual and will be formed behind the mirror, and that is what makes it virtual. So let's look at the other question in the next video. Don't forget to like, share, and subscribe.